Hey everybody, thank you for coming to today's webinar. One quick note, make sure to keep your mics off and also make sure to keep your webcams off during the webinar. So today what we are going to cover is combinations. We're going to do another 45 minutes here today as Scott is not able to join us. Now, what I want to cover in today's webinar is probably sticking more to combinations rather than permutations, but I just wanted to speak about that briefly because one of the things that people struggle with when they come into their GMAT prep is they always say, especially with combinations and permutations, is how do I know when I'm dealing with a combination versus a permutation? So, with that in mind, it's one of those things that I think has become everyone's reality. It's actually not as bad as it has once seemed. And so I want you to understand by the time you're done, especially with our materials going through the combinations chapter versus the combinations chapter in general, you will see that combinations are quite clear, and when to deal with a permutation is also quite clear. With that said, for any of you here who have not had the opportunity to use our course, we do have a slight sale going on at the moment, so feel free to take advantage of that if you want to do a trial and then possibly upgrade. It's going on for another week, so I will put that into the chat box. So, of course, you can take a look at that. So what I want to do is I do want to get started with a fairly basic basic combination, and then we can kind of go from there. And after we do this question, what I'm going to do is kind of explain why I feel like this is a combination, versus a permutation and stuff like that, so everyone feels like they're on the same page there. So give me 1 sec. I'll put the problem up. Then I'm going to give everyone about 2 minutes. Put your answer in the chat box when you get it, and then we'll go ahead and review the question. Okay, so it was about 2 minutes here, and as I said, I want to kind of discuss the type of problem this is. So obviously I said this is a combination. So it is. And what that means is that in a combination, I'm sure you've heard this a million times, order does not matter. And it's true, order doesn't matter in a combination. And when I think of combinations, the first thing that comes to mind is a team. And if you're picking people for a team and there's nothing specific about that team, if, Abby, Jack, and Tom are selected for the team, or, Jack, Abby, and Tom, just in a different order, it's still the same team. When you get into permutations is when you're dealing with things like line arrangements or specific components of teams. So if we're going back to the whole team idea and we're talking about a baseball team, well, the minute Abby, Bob, and Jack, if those are the names I used, have to be put into a position, say pitcher, catcher, and first base, well, now all of a sudden, because whoever is at a particular position changes the arrangement of what the team is, now we're dealing with a permutation. So back to this problem, well, we're talking about cheese and we're talking about veggies. So if you can imagine creating a pizza and you decide that you want to put 2 cheeses on a pizza, and let's say you decide on mozzarella or Parmesan, the pizza will be the same if you decide on Parmesan or mozzarella. So that in itself means that order doesn't matter. And this is not something I want people to overthink or anything like that, but it is something to keep in mind and understand that when you're on the test, it shouldn't come down to, is this a combination or is this a permutation? So with that said, as we move through this question, we're recognizing that we have 2 components to our combination, and I call these buckets. So we have the cheese bucket, and we have what's called the veggie bucket. Now, with that in mind, we know that there are 4 cheeses, and we want to select 2. So that's going to be 4 choose 2. And that's how I like to write it. And then I don't use the combination formula. I use something that we call the box and fill method to solve my combinations. And so what I do with the 4 choose 2 is I say, all right, well, there's 4. We need 2. There's 2 spots that we're choosing from because we're selecting 2 different cheeses. So I put out 2 slots here, and I count downward, and I say, well, we have 4 possible cheeses for the first position and 3 possible cheeses for the second position, and then because it's a combination and because there were 2 original spaces, I set that to a factorial, do some math, I get 6. Now the veggies is easier, so anytime you're doing something choose 1, the answer is always the original something. So 3 choose 1 is 3, 10 choose 1 is 10, 100 choose 1 is 100. So that's something that you can kind of tuck away and use. So we have 6 times 3, we have 18. So hopefully that wasn't too bad for anyone. That is a basic combination. And, the other thing too, for people out there that, like to read about people are saying about things to know for the GMAT and stuff like that, one of the things I hear a lot too is like, okay, I'm probably not going to be asked that much about combinations. So if there is one topic that I could skip, it would be combinations. And I want everyone to keep in mind that, you never know what you're going to get on the test. So I would never suggest, skipping an entire chapter, based on a hunch or what you see other people saying. So with that said, I'll give everyone another 2 minutes, and then we'll get going on this problem here. All right, so it was about 2 minutes, and this problem is actually quite similar to the last one we did. As you'll see in the last question, as I mentioned, we have our different buckets. We had a cheese bucket and a veggie bucket, so it was very obvious to say cheese is one thing, veggies is another thing, and then move forward from there. Now, in a question like this, it's a little less obvious, but if you're looking for it, you may just be able to find out what these categories are. And they're implying a lot here, because the question says if a pirate picks 5 jewels from the chest, and then it says 3 of which are rubies. So what that means is that there have to be 2 other jewels taken. So that means that what are the other 2 jewels? Well, if 3 have to be rubies, the remaining 2 can't be rubies. So then we have what's called a ruby bucket and a non-ruby bucket. What we say about our ruby bucket is since there's 5 rubies and we're selecting 3 of them, that's 5, choose 3. And the non-ruby bucket, because we see that we have 7 non-rubies and we need 2 of them, would be 7, choose 2. Now, just like the last problem, both of these situations, this is one event, so we're multiplying the combinations together once we get them, following the same approach I just used. 1, 2, 3 slots, 5 times 4 times 3, divided by 3 factorial, so that's 3 times 2. Notice I'm always canceling because I don't want to do, math on top and then have to divide by big numbers on the bottom in the divisibility. And then 7 choose 2 is just 7 times 6. You divide by 2 factorial, you get 21. So the answer is 10 times 21, which is 210. So hopefully, again, no one thought that this was that bad, and hopefully you saw the similarities between the first problem and the last. But now I actually want to get into problems where you have to start thinking about addition and problems where the word at least starts to play a role. And this is a great example of that here. So this one, I'll give everyone about 3 minutes to try this, and then we can discuss exactly what's going on here versus the other problems we just did. Okay, so it was about 2 to 3 minutes there. Now this is an interesting problem because this is the first problem where we're now dealing with scenarios. So to be clear, everything we did up to this point was one singular event. How many ways can he pick the jewels? Well, we picked rubies, we picked on rubies, that was an event. We picked cheeses, we picked veggies, that was an event. So when there's just one event, it's very clear that you're just dealing with straight up multiplication. However, when you are dealing with scenarios like this, it's clear that it's not just one event. You know, it's kind of like saying it could either be sunny or it could be cloudy today. Those are two different events. They don't happen at the same time. That's what's going on here. So we'll notice that it says that the team must have at least 2 Iranian players. So what that means is that we're in a situation where there are multiple ways this team can be formed. Multiple ways means that we need to make these different scenarios, and then we ultimately add these scenarios together. So with that said, the first thing we want to do is come up with what our different scenarios can be. So one possible scenario, which we'll label S1, is going to be 2 Iranians and 2 Turkish players. Because remember, we have a 4-person team. Now, 2 Iranians and 2 Turkish players is going to be solved by saying, okay, we have 6 Iranians and we need 2 of them. So 6 choose 2. We then would do the math out and we'd say, okay, well, there's 2 slots. So we do 6 times 5 over 2 factorial, do some reducing, and we get 15 for the ways to pick the 2 Iranians. So with that said, the next thing we do is the Turkish people, where you have to do 5 choose 2. Because there's 5 Turkish players, we need 2 of them. Once again, 2 slots. We count downward. We cancel. We get 10. So the number of ways for 2 Iranians, which is one event, is 150 ways. Now, we're not done there. Notice 150 is an answer, but we still have 2 more scenarios to go because we didn't fulfill what they were asking, which is how many ways we could do this with at least 2 Iranians. So scenario 2 is going to be 3 Iranian players, 1 Turkish player. So that would be 6 choose 3, do 3 slots, 6 times 5 times 4, divide by 3 factorial, do the math out, and we get 20. 1 Turkish player, as I taught everyone, is very simple. 5 choose 1 is 5. 20 times 5 is 100. So we're getting there. 250 is the sum of 150 and 100. And remember, the reason why we're adding those scenarios is because they're not happening at once. They are separate, different, distinct events. And I know this is something you probably learned a little bit more in probability, but it's something that you're going to have to kind of reapply with combinations. So in scenario 3, well, now we have 4 Iranians. The whole team is going to be consisting of Iranians. Again, we know there's 6 of them. So 6 choose 4, do our slots, 6 times 5 times 4 times 3. We're going to divide that by 4. Oops, sorry about that. We are going to divide that by 4 times 3 times 2. Notice that is 15. So when we sum all of these guys together, we get a grand total of 265. Now, some of you may think, you know, this is pretty time consuming. Am I really going to be able to do this on the test? And the reality is it's not that time consuming because the amount of thought that has to go into this question is pretty limited. Like once you know where you're headed, and you can write out these scenarios and quickly and efficiently deal with your combinations, it's actually a pretty easy question, but yet it's probably considered a 700 level question. So what I love about combinations that most GMAT students don't kind of think about is the fact that the scope of these questions is pretty limited. Like, it's a hard topic, so they're not going to go too far outside the scope. And what I want you to see is that, like, what we did here is we did 3 separate combinations, which were all very similar to what we did here and here. So if you can do this question, you should be able to do this question, and you should certainly be able to do this question. Now, there are certain times where you can do things a little bit more efficiently, which we are going to talk about right now, and you're going to find that the next question we do is going to seem almost identical to what we just did, but I promise you there's a difference. So read it carefully, and I'll give everyone about 3 minutes, and then I want to talk about the different ways to look at a problem like this. Okay, so that was a good 2 to 3 minutes here, and this is a pretty cool question, and it is taking some principles that everyone has pretty much learned in probability, but a lot of times, I remember when I was starting out, no one ever taught me the relationships between probability and combinations. And as you move forward, especially through our materials, you're going to find that the relationships are very strong. And a lot of the things and a lot of the ways that you're thinking about a combination question can be identical to what you're doing in a probability question with a few additions. So why am I saying this? Well, a classic probability question is, and I'm just going to type this on the screen, how, Jack flips a fair coin 5 times. What is the probability he gets heads at least one time? Okay, so everyone's seen this question before. This is not news to anyone. I'm sure you've seen a coin question and you've seen it at least one time. So in a question like this, instead of doing all the different ways he can get heads within the 5 flips at least one time, the way to do it is to say, you know what, I'm going to do 1 minus the probability that Jack never flips the heads. And that's a more efficient way to do it. And the key in this question to know to do it that way is the word at least one or at least once. That is a key component that says, you know what, we can do it the other way. And there's no reason why we can't do it in this problem too, because if you really think about what we're dealing with here, we can make a formula that says the total ways to select the team equal the number of ways of 0 Iranians plus the number of ways for 1 Iranian, at least 1, plus, not at least 1, plus the number of ways for 2 Iranians, plus the number of ways with 3 Iranians, plus the number of ways, and I'm running out of room, for 4 Iranians. So that, if we do it this way, this is going to take us a whole lot of time because literally we would have to come up with 4 scenarios. Now, I do realize that we did 3 scenarios in the last question, but adding a 4th one, if we don't need to, is never that fun. So why not just say, you know what, I'm going to do the total ways to select the team. I'm going to subtract the number of ways in which I get 0 Iranians, and that's going to equal the number of ways to get at least 1 Iranian. And like I said, this shouldn't be crazy because we do this in probability all the time. I just feel like when it comes to combinations, maybe we don't think about it as much. So now life is kind of good, assuming we feel confident doing combinations. And we say, okay, we have 5 players from Turkey, 6 players from Iran. So we have 11 choose 4. So that becomes 11 times 10 times 9 times 8. And of course, we're doing over 4 factorial. 4 times 3 times 2. That cancels, so then the math is getting kind of large. We end up with 30 times 11, which we end up getting 330. Now, the next thing here is we just need to do the number of ways for 0 Iranians, so all Turkish people. So we're talking about 5 players from Turkey on a 4-person team. That's going to be 5 choose 4, which is simply 5. And this is another point that I could have mentioned at the beginning. Anytime you have like 5 choose 4, 10 choose 9, 20 choose 19, the answer is always the value that's on the left. So we don't have to actually do the math out for 5 choose 4. We know that it's going to be 5. And then the last step here is literally we subtract 5 from 330. We get 325. And that is our answer, answer D. So this may be a good place to stop. I think we've talked about some really great points today. You know, the one thing, and I was just telling my student this last night because she had taken an official test and I was able to kind of triangulate a question that she did in her practice exam, official practice exam, I mean, from MBA.com, and in an old official guide question. And the thing is, like, they like to repeat different ways of asking questions. So if you can break down every question to its core skill, what's being tested, how to attack it, your success is going to be tremendous on the GMAT. There has to be a rhyme and a reason to why they're giving questions, which means something is being tested, some skill is being tested. So the more that you can get granular with your prep, and I know our students at Target Test Prep do this, the better off you're going to be come test day, because you're not going to care how they present a question to you. You're going to know how to deal with it because you understand that the core skills are being tested. Now, next week, we're going to do some probability, so chances are I'm going to be kind of dealing with the probability stuff along with showing how combinations play a role in probability, and so hopefully everyone can make it to that as well. But as always, we want to thank everyone for coming. You know, this has been a great session, so hopefully everyone learned a lot, and we will plan on seeing everybody next week. So thanks again, everyone, and if you need anything, feel free to reach out to Scott or I. Talk to everyone soon.